All right, so let's continue our discussion about box and whisker plots, and let's just talk about the 5-number summary. You will often be asked to give the 5-number summary for a set of data, and we just want to know exactly what that means. So a couple things. Number one, the minimum and maximum values alone don't tell us very much about the distribution of a whole. It doesn't tell us where most of the data lies, etc. If we just look at the median and the quartiles, that only tells us about the center of the data. It doesn't describe the ends of the data. So in order to get a quick summary of the whole set of data, the center, the spread, we have to combine all 5 numbers. We have to look at the middle of the data and the ends of the data. So thinking of that, whenever you're asked to construct a 5-number summary, we want to make sure that that represents the data as a whole. So the first thing you're always going to do is make sure you put it in order from largest to smallest, and once you do that, you want to find the minimum value, the first quartile, the median, the third quartile, and the maximum. So specifically when the directions state give the 5-number summary, these are the 5 numbers that you want to provide because they give us a good idea of the spread of the data, the middle percent, the entire range. They give us a good idea where the center is and the smallest and the largest values. Now, box and whisker plots allow us to take these 5-number summaries and divide it into quartiles or quarters. Whenever we display box and whisker plots, okay, we use that 5-number summary to create the box and whisker plot. Most important, please make sure that you always calculate the boundaries for the outliers. Anytime you have a box and whisker plot on the AP exam, on whether it's an AP exam, your homework assignment, please make sure you show the calculations for the outliers. Don't just state what the outliers are, show the calculations on how you got them. Make sure you draw and label a number line. Make sure it actually has numerical labels on it and a label to tell what you're looking at. You draw the box from quartile 1 to quartile 3. You put a line where the median is in the center of the box, and then you make whiskers from the quartile 1 to the minimum and the quartile 3 to the maximum. Please note that you do not include outliers in your box and whisker plot. So from now on, we're going to use something called a modified box and whisker plot. You do not include outliers with the whiskers. You include them as single dots at the end. So you'll extend the whiskers from quartile 3 to the maximum value before the outliers, and then from quartile 1 to the minimum value before the outliers, and you'll make the outliers as little dots, okay? They'll be like little dots or stars on your graph, and that's specifically showing that they were outliers, just to make sure that you show those calculations on how you got the outliers. All right, so let's take a look at this one. Our New York travel times data. So we put it in order from least to greatest. We have our minimum, our maximum, our median, our quartile 1, and our quartile 3. All right, we all have those calculations. Notice my minimum is down here. Here's my quartile 1. Here's the median, quartile 3, and then notice this doesn't extend all the way out to my maximum. Okay, the maximum was 85, but this was an outlier that we discovered on an earlier slide, so we only extend it to the maximum value till we hit the outlier, so that was 65. Okay, 65 is the largest value that we have before everything after that would be an outlier. Okay, and on a previous slide we had the calculations for the outliers. Make sure those are included somewhere. Also notice we have a numerical scale and we have what the box and whisker plot is. It's specifically looking at travel time. Okay, so a couple of things. Here's just some common errors. Please make sure that you do not refer to the box in the middle as the IQR. The IQR is not the whole box. It's specifically the length of the box and not the box itself. So we would say the IQR is 15 or whatever. So that's telling us that the spread of the middle 50% of the data is only 15. This is really important, and you're going to have to remember this, especially for later on. Don't ever say that a box plot is approximately normal. We don't know if it's approximately normal. We can say it's symmetrical, is when the median's in the middle of the box and the whiskers are about the same length, but we don't know about the if it's approximately normal unless we've graphed a histogram. So don't ever state that a box plot's approximately normal. Okay, so if we look right here, we have our our outlier over here, we can state that this is about skewed to the right because we sort of have a longer right tail than a left tail. All right, so how I sort of was talking about the shape in the last slide. So let's just see how we can figure out what the shape is from a box plot. Think about a histogram. We have a histogram and we have this nice long right tail. Over here we sort of have a short left tail. That translates to a box plot in the sense that your right hand tail is going to be much longer than the left hand tail. Now also kind of notice where the median is. Okay, your median is a little bit closer to the left side of the box, and that's because most of the data is on the left side. If we take a look at a histogram that is left skewed, notice how we have a long left tail, okay? And so that corresponds to your box and whisker plot and the fact that this long left tail is much longer than the right hand tail. I would suggest looking more at the whiskers more than the placement of the median. So it's much easier to see that this has a long left whisker than a right whisker, so that's going to be left skewed. That corresponds with the long left tail of the histogram. So like I said, can look more at the whiskers than you do at the placement of the medians. All right, so let's just get a little bit of practice. What I would like you to do is, below is the data for incomes in thousands of dollars of 12 households. Go ahead and number one, find the 5-number summary for the data. Now you can do this on your graphing calculator or by hand, doesn't matter. Take a minute and calculate the IQR. Remember specifically the IQR is a number, and when it says interpret it in context, that's like saying the middle 50% of the data lies between blank and blank. The middle 50% of the data range is blank. In context, make sure you're specifically stating the middle 50%. Go ahead and draw a box plot of the data. Make sure you show the work for the outliers. If you don't, it's incorrect. And then you want to make the decision based on the shape. Would you use the mean or the median as a measure of center? So go ahead and try that. Hit pause and then take a look at the answer on the next slide. Okay, so remember, 5-number summary, always put it in order. Minimum, quartile 1, medium, quartile 3, maximum. Notice the interpretation for the IQR. The range of the middle 50% of the data is 14 pounds. Okay, so please, please, please make sure that you state the range of the middle 50% of the data. Notice for the box and whisker plot, we have a numerical and a description as part of our labels. Here's my outlier. Okay, notice though that I don't have outliers without calculations. Here's my outlier. This is your quartile 1 minus 1.5 times your IQR, quartile 3 plus 1.5 times your IQR, and that gives you your upper bound. Now notice it doesn't necessarily, you don't extend the graph to 345, you extend it to the largest number as part of your data before you get to 345. Okay, when you take a look at this graph, the right whisker is a little bit longer, so that means it's probably slightly skewed to the right, so we're going to use the median as the measure of center. Also, usually when you have outliers, you're going to use the median as a measure of center since it is resistant to them. Just remember, in the calculator folder, there's instructions on how to create box and whisker plots, along with how to do the 5-number summary on your TI 84 and TI 89. All right, so how do we measure the spread? When we get to normal distributions, which is what we're going to be talking about most in the class, the most common measure of center is how far each observation is from the mean. This is called the standard deviation. That's what you're going to be using the most. So let's just take a look at the following data on the number of pets owned by a group of 9 children. Okay, so we did a nice dot plot here of the number of pets owned by 9 children. We want to do a couple of things. Number one, since standard deviation tells us how far we are from the mean, we have to calculate the mean. And then next we're going to calculate the deviation. That's how far each point is from the mean. All right, so just deviation in general is how far each individual observation is from the mean. Okay, so we calculated the average. The average number of pets is 5. That's right here. Okay, a deviation, for example, 1 right here is -4 because we took 1 minus 5 to give us that's 4 below the mean. Okay, the deviation for 8 pets is 3 because that's 3 above the mean. So how do we translate that then to a standard deviation? So deviation is how far one data point is from the mean. standard deviation says, what is the average distance from the mean? All right, so what we're going to do is we have each of my 9 data points. I'm seeing how far each deviate from the mean. Okay, how each of my 9 data points deviate from the mean. All right. So then what we're going to do is we're going to take that and we're going to square that. Well, why do we square it? We square it to make it positive, and when we square it to make it positive, that just tells us in general how far something is from the mean. So, and it could be on average, that could be above or below the mean, but we always want our standard deviation to be positive. All right, then what we do is we see how far they are away from the mean, square it, add up all of these, and that gives us something called the variance, okay? This number right here, down here at the bottom, is called the variance. Honestly, that's not something that we're going to use very often. We actually want the square root of the variance. The variance is just a way to get to the standard deviation. So what we do to get the variance is we take the square root of the variance to get the standard deviation. And that standard deviation tells us how far, on average, the number of pets owned is from the mean. So on average, if the average number of pets is 5, on average, people own 2.55 more pets or 2.55 less pets. Okay, so that's on average, and that sort of means above and below. All right, please, whenever you're interpreting the standard deviation, make sure that it's in context. So an example of that, as I said on the previous slide, the number of pets vary by 2.55 from the mean number of pets owned by children, which is 5. You don't have to say it exactly like that. You could say the mean number of pets is 5. On average, the number of pets owned varies about 2.55 from the mean. So they could own 2.55 more pets or 2.55 less pets. The standard deviation measures the average distance from the mean. Remember, it's always calculated by finding the average of the squared distances and then taking the square root. That average was the variance. We literally use the variance just to find the standard deviation, okay? Now, you're going to see 2 types of standard deviations you're going to find 2 types of standard deviations on your graphing calculator. Okay, 2 different types of standard deviations from your graphing calculator. One is going to be a population standard deviation. That you're only going to use when you have all of the data defined as your population. When using your calculator, most of the time you're going to use the sample standard deviation, which is S of x. That's the sample, unless you know the data from the population. Most of the time you're not going to know this. You're just going to be given a sample. So you always want to make sure that you take a look and you're using the correct standard deviation from your calculator. Okay, so just a couple of things about the standard deviation. Number 1, the standard deviation measures the spread about the mean and should only be used when the mean is the measure of center. Don't use it when you've chosen the median. That doesn't make sense because it doesn't tell us how far something is from the median, only from the mean. The standard deviation is always going to be greater than or equal to 0 because it's squared, so it's never going to be negative. If the standard deviation is 0, that means there's no variability. Everything is exactly the same as the mean. So this is basically when all observations have the same value. And the more spread out the values are, the larger the standard deviation because the average distance from the mean is more. The standard deviation has the same units of measurements as the original observation, and the standard deviation is not resistant to outliers. A few outliers can make the standard deviation very large.